You'll see that with the Lowndes method, I give you an extra table dedicated solely to those ratios where we're going to see who gets the extra pieces. So to begin, we still start the same ways as all of our other methods for apportionment. We need to start by finding the divisor. 133,000 divided by how many seats? We're apportioning 35 seats. I took my total population, we divide it by 35 to get our starting divisor of 32,371.4286. No, come on. 6. Dang it. Four, 2, 8, 6. I made it fit. All right, that's going to be our starting divisor. Each quota is that state's population divided by this divisor. Now you need at least three or four decimals, okay? 3 is fine. I'll say 3 is fine. I know I've kind of wavered back and forth on that. 3 is okay, but you need more than 2. I'll say that. So, Adams County, I see we're doing counties, not states. I probably said states. It's fine. Is going to be 6.425. All right, 13.645, 5.035, 6.487, and 3.398. I'm copying those for, you'll see in a moment. Our initial is the cutoffs. 6, 13, 5, 6, 3. And it's going to be smaller because this is rounding every single number down. It's going to be smaller, but we need to know how much smaller. How many extra seats are we adding? So 19, 24, 30, 33. We needed 35. So there's 2 extra seats that need to be added. In Hamilton's, let's just talk through Hamilton's real quick. It's not what we're doing here. In Hamilton's, we would go through and we would give them 1 seat because that's the biggest. And then the second seat would go to them because 4.8 is bigger than 4.2. And those were the second largest decimals. That's how Hamilton would work. We would assign those extra seats, be done. But for Lowndes, we now take the quotas. That's why I just copied those because I'm going to paste them down here in our little quota space. And we calculate these ratios. Now the ratio is the decimal part divided by the whole number part. So it's going to be 0.425 divided by 6. And that is 0.071, roughly. All right, it's rounding. Here, this is going to be 0.645 divided by 13. The decimal part divided by the whole number part. That's going to be 0.050. All right, 0.035 divided by 5. That's 0.007. 0.487 divided by 6. That's 0.081. And finally, 0.398 divided by 3, 0.133. So instead of in Hamilton's where we just look at the decimals and see which one's highest and award them, we are now looking at the ratios and seeing which is highest and award them. So first place, 0.0, 0.0, 0.0, 0.1. First place is actually Hayes. All right, I went decimal by decimal. They have the highest value. So Hayes is definitely getting one. We have 2 extra seats that need to be awarded. Hayes gets one. And who gets the second? Well, 0.0 on all of the rest. So let's go to a second decimal place, 7,508 for the second place. So Davis gets the second one. Davis is the second highest ratio. They get the second seat. So Hayes and Davis. So going back up to show my final, those are where I'm going to add the extra seats to. Davis gets one and Hayes gets one. So my final allocation is 6 for Adams, 13 for Grant, 5 for Colton, 7 for Davis, and 4 for Hayes. And if I add all these together, I get the 35 seats that I was supposed to award. So these are my final allocations. One more example I really like before you even go to the next video, go try it out on your own.